Problem 48. In the circle shown below, chords TR and QS intersect at P, which is the center of the circle, and the measure of our angle PST, where's PST? PST, the one labeled 30 degrees, that's going to be 30 degrees. So what is the angle measure of minor arc RS? So it's asking us for minor arc RS. Remember, the arc of a circle, or a minor arc, is going to be the portion between 2 points, kind of like a curved line segment. Those points are going to be on the circle for it to be an arc. So like this would be arc QR. This is arc RS. This is what the one that they're asking us about. Okay. Important to remember for this theorem is that the arc angle, or the degree measure of minor arc RS, is going to be the same as the angle measure of this angle RPS. So if we can find whatever this is, that's going to equal the angle measure of RS, the arc. The arc, not the line segment, the arc. So how do we find this? We know that because it's a circle, we know the addition of all of these all these angles inside here is going to equal 360 degrees, because 360 degrees is like a full circle, right? That's how many degrees are in a circle. So 360, this is another theorem, 360 degrees is going to equal angle RPS, which we're trying to find, RPS, plus angle RPQ, plus the measure of angle TPQ, plus the measure of angle TPS. And again, that's just the angles of all of them that encompass the inside. And it's also important to note that these vertexes of those angles lie on the circle. So if there was a vertex that was like inside here, that might not be the case. But since they all encompass all the areas and all the points are on the circle, we have our theorem. So because they all add together, let's see if we can find the measures of all of them and then simplify to find our value here. Simplify to find that value. So using our information that we know, it's always good to start with the information that we know. We know this is 30 degrees. We also know that a triangle has 180 degrees total, and those 180 degrees are going to be the sum of the measures of all angles. We'll do all angles added together. So that's going to be the angle here, the angle here, and the angle there. The sum of all of those is going to be 180 degrees. So we already know one angle here. So we know that 180 is going to equal 30 plus 2 more angles. So we have a theorem, another one, a lot of theorems for geometry, right? Because these two lines are intersecting at point P, and because each one of these line segments, QS and RT, because they all have points that lie on the circle, we know that the line segment TS is going to create 2 equal angles. So we know that angle RTS is going to equal angle QST. Now, I just have to keep track of essentially these 2 angles are going to be equivalent. So there's another angle. We have 30. We have RTS, which is 30. And now we can find this interior angle here, which would help us with our initial equation for finding these interior 4 angles here, these ones, right? So then we can solve, let's call this angle X. We know that 180 equals 30 plus 30, which is 60, plus our X, we carry that down. We subtract 60 from each side. In order to isolate X, we're isolating our variable to get 120 equals X. So now we know that this angle TPS, equals 120, because that's our X value. And that's this angle right here. So we found one part of the puzzle. The next piece of the puzzle is we know that vertical angles, so if we have 2 intersecting lines, these are the vertical angles. So if this is angle 1, this is angle 2, we'll call this angle 3, and this angle 4. We know angle 1 is congruent to angle 2, and we know angle 3 is congruent to angle 4, which also means, we know angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, which also means that their measures are equal. The measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is equal to the measure of angle 4. So their number is going to be equivalent. So because TPS is 120, we know that QPR is also going to equal 120, or RPQ, same angle, right? Just call it a different name, equals 120. Vertical angles, that's what they're called, vertical angles. These two right here. Then this last angle is another set of vertical angles. So let's go back to our initial equation. We have 360 equals RPS times 2, because this angle is going to equal that angle. This angle RTPQ is what we called initially, TPQ, is going to equal RPS because they're vertical angles, just like we did for the first two, this one and this one, the one counted for x. Those two are going to equal as well. So we have 2 times angle RPS is going to equal TPS plus RPQ, these two angles. So it's doubling this one, or this one plus this one equals double this one, because they're the same. And then that plus, we have TPS, which is 120, and RPQ, which is 120, is going to equal 360. So we can simplify and isolate our variable. 2 times angle RPS plus 120 plus 120 is 240. Remember, you can use your calculators. Subtracting that to the other side, we have 120s left over after we subtract, equals 2 times angle RPS. And then we can divide by 2 to get RPS alone. So 60 is going to equal angle RPS. And because RPS is 60, that means the arc here is also going to equal 60 degrees because they're equal. That's what we said at the beginning. So our answer is H, 60 degrees.